Welcome to this video, and in this video we are going to discuss finding the equation of an exponential function. Before we get started with finding those equations, let's review a little bit of our exponent rules. Okay, so if you have anything raised to the 0 exponent, that is always equal to 1. All right, and if you have something raised to a negative exponent, you move it to the bottom of the fraction, the denominator, and it changes that to a positive exponent. So a couple of examples here would be if I have 5 to the 0, that is equal to 1. Okay, if I have 1 million raised to the 0 exponent, that is equal to 1. All right. If I have 5 to the negative 2, that is the same as 1 over 5 to the positive 2. All right. And similarly, if I have, let's say, 6 to the negative 1, that is 1 over 6 to the positive 1, which is just 1 over 6. Okay, so that was just a quick review there to refresh your memory of your exponent rules. So when we work with exponential functions, we are dealing with this f of x equals b to the x, and basically your exponent is the x variable in the equation, and that's why they're called exponential functions. And basic exponential functions, we always assume that b is not equal to 1. So b can be a fraction, okay, or it can be something greater than 1, but you're not going to use a 1 for b, okay? And it's also always a positive number, okay? So your b is not going to be a negative number. And you can see here they're kind of talking about why you don't use a 1. If you, no matter what exponent you raise 1 to, it's always equal to 1. So it really doesn't make sense to have a base of 1. And for your basic exponential functions, you always have a domain of negative infinity to positive infinity and a range of 0 to infinity. Now this is a basic exponential function, and what I mean by that is there's been no transformations done to it. It hasn't been shifted to the left or the right or up or down, and it's just your basic standard exponential function. Once you get into transformations, you will see that your domain and your range will change accordingly because of the transformations. So here are just a few quick graphs that we can talk about, and these are what we consider basic exponential graphs. You see here that your base has changed. I have a base of 2, I have a base of 3, and then I have a base of 1/2. Okay, and that does change the look of the graph. Okay, but if you think about each of these points will always have this 0, 1. Okay, so if I plug in a 0 for x right here, I have 2 to the 0, which is equal to 1. So that means the point 0, 1 will be on the graph. Similarly, if I put in a 0 here, I have 3 to the 0, and that's equal to 1. Okay, and down here, if I put in a 0, I'll have 1/2 to the 0, and that's going to give me 0, 1. So that's something that you will see as a common characteristic when you're working with your exponential functions. Now this first graph here, this is what we consider exponential growth, and this one is also exponential growth, whereas this third graph here would be considered exponential decay. All right, your growth is getting bigger, your decay is getting smaller. So if you look at the next slide here, if your b is between 0 and 1, as they're showing here, you're going to have your decay. If your b is greater than 1, you're going to have your growth, or decay or growth. So let's look at a few examples here. So let's figure out how to match these up. So if you look at part A here, this is going to be an exponential growth, and it has to be this first graph here. Okay, so you can see that as an exponential growth. And if you look at part B, this is going to be an exponential decay, so that has to be this one down here. Now if you look at C, what we have here is a situation where we have exponential growth, but then it's been reflected, right? Remember our transformations, you have a negative out front and it's been reflected over the x-axis. So that's going to be this one. Okay, so basically if you think about your graph of A being reflected over the x-axis, you would have this graph over here. And then similarly with D, you have an exponential decay that has been reflected over the x-axis, so it's going to have to be this one. And you can see it's taken this graph here and think of reflecting that, and you can see that it will look like this over here. So kind of interestingly enough, these graphs always level off. Okay, so if you want to think about your asymptotes here, right, you have an asymptote going across here at y equals 0. Right, you have an asymptote here at y equals 0. You have an asymptote here, y equals 0. Hope you're catching the pattern. And down here you have an asymptote of y equals 0. So these are all leveling off. Now they're leveling off in different ways as far as how they're approaching that horizontal asymptote, but they all are approaching this asymptote, which creates them to flatten out either on the left side or the right side. So let's do a couple of basic examples here. So we have a graph that's given, and you can see it's obviously exponential, and then they identified a point here as well, and they want us to find the exponential function that represents this graph. So we have this f of x equals b to the x, which is your basic exponential function. Remember, you can always think of f of x as y. All right, so if you think, okay, I have y equals b to the x, we need to figure out what this b value is. What is the base? Well, this is an exponential growth graph, right? If you look at the graph, you can tell it's an exponential growth, so we know the b is going to be greater than 1. That's just something to think about as you're looking for you know, the value, kind of check behind yourself. And you can put your y value in for y, which is 25, your x value in for x, and then solve. Okay, so what they did here is to solve for b, they took the square root of 25, which is 5, and that gives us our base. So our exponential function would be f of x equals 5 to the x. Now a little side note here, technically when you have a situation where you're taking the square root, you technically take the positive and negative square root of that number, okay, and that is going to come up as we get to a lesson down the road. But one thing you have to remember is that your base is always a positive number with exponential functions. So we actually don't have to think about taking the positive and the negative root. We can just think of doing the positive root because our base is always a positive number. So here's another example, and once again they've given you a graph, and this is a exponential decay, right? You can see by looking at it, and we're looking for this y equals b to the x equation, and we can use this point, right, to figure out what that base is. So what they've done is they have put in the 0.125 for your y and the 3 for your x. So that gives us this setup here, okay, and you put in the 0.125 for the y and a 3 for the x. Now you can see here they did choose to go to the fraction, okay, of 0.125, and your calculators will do that conversion, by the way, a decimal to a fraction, so I encourage you to try that. But you could leave this as the decimal if you prefer to do that, okay? It's just, you know, they're just showing you one option here of going to the fraction. And then to solve for b, you have to take the cube root of the 1/8, and b is 1/2, okay? And then you rewrite your function with that base written in there. And I'll show you real quick how to do the cube root on your calculator. So let me pull that calculator up 1 second here. So if we want to take the cube root of 1/8, your calculator will do that. You can see down here you have this cube root function, and you have to use your second key since it is above the button there. And your calculator will take any root you want it to take as long as you tell it which one you're taking. So in this case we're taking the third root, so I want to type in 3, hit my second, and then this key here, and you can see up on the screen now it knows I want to take the cube root, then hit my fraction key, and then type in the 1/8, and then you can hit your enter key, and your calculator will tell you 1/2. Okay, so this is a nice calculator in that it will take whichever root you need it to take. And also I wanted to show you that that fraction to decimal conversion is down here. Now sometimes it will not convert, I will say, but a lot of times it will. And you can see here I typed in the decimal, and then I did second, and then hit the fraction decimal conversion, enter, and it did tell me 1/8. Okay, so those are just little side notes of how to use some of the functions on your calculator. Let's go back to the problem. All right, so let's move on to another example. And this is where we're going to build in what we call our transformations or our changes, okay? So we're no longer looking at just a basic exponential function. We are now looking at something that involves some type of transformations. So you can see there's a number out front here, and there's a number over to the side here, and those are transformations that have been done. So you always want to use a b to the x plus c, although you will see it done with different letters sometimes on different videos and different textbooks. Also, if you want, you can use capital letters. Oops, I don't know what I just hit there. So you will see it done with capital letters sometimes instead of lowercase. It does not matter, okay? It all means the same thing. And this is a cute little saying that might help you, is you take a cab to the answer. So first you figure out the C, then you figure out the A, and then you figure out the B. Your C is always going to come from your horizontal asymptote. So you can see in this particular one here, the horizontal asymptote is coming across at 3. All right, and then we work from there to find the A, and you use the y-intercept, where the graph crosses the y-axis. And then they'll give you another point, or there'll be a way to identify another point on the graph, and you can see here this is that other point. So let's talk through this solution here. So first they found C. Okay, so C is 3, and that once again is coming from that horizontal asymptote. Okay, and so now we know that for C we have a 3. And then for your y-intercept, they have gone back to the equation and they have plugged in this point. So they plugged in a 4.5 for your y value, or f of x, and they plugged in a 0 for the x. Okay, and you can see the 3 is still in there from our previous step. And then this allows you to solve for A. All right, so remember what we talked about earlier in the video, that you have, whenever you have something raised to a 0 exponent, it's always equal to 1. All right, so you can see this becomes a times 1, and then they can just subtract the 3, and then you've got your solution for a. So now they have put in the a value along with the c value, and now you must find your b. So for b, they're going to put in this other point here. So they put in a 6 for the y value. They put in a 1 for the x value. You can see the a value is still in there and the c value is in there, and this allows you to solve for b. Okay, so b to the 1 is obviously just b. All right, and they subtracted the 3 from both sides, and then they divided by 1.5, and you get b equals 2. So then all you have to do is rewrite your function with the a, the b, and the c. So for this particular function, okay, you could write it as y equals 1.5 times 2 to the x plus 3. You can see I used a y instead of the f of x. I also like to use parentheses around the base, as you can see here. You don't have to do that. For me, it helps the problem to read correctly. Or if they specifically want that function notation, then put the f of x. All right, and like I said, probably best to put the parentheses around the 2. Although what is down here is okay, and that's a valid way to write it. So let's go on to this next problem here. So I want you to pause the video, and I want you to try to do this problem. Okay, think about whether you're dealing with exponential growth or decay, and take a cab, right? Take a cab to the answer. So you want to find your C, your A, and then your B. All right, so pause the video and give it a go, and then you can see how you did. Okay, so I have worked through the problem, and the first thing you do is find your C value, which comes from your horizontal asymptote, and C is -1. And then you want to think about the equation, okay, with that C value written in there. And then you're going to find your A. All right, remember you're taking a cab to the solution. So you find your A, and you want to use your y-intercept to find your A. So I have plugged in a 2 for the y and a 0 for the x, and then I solve for A. Now remember, once again, you have this b to the 0. All right, b to the 0 is just 1. So you have a times 1, which is just a, and then I added 1 to both sides, and I get an a value of 3. Then you're going to find your b. So you think about this, okay, this equation where I put the a and the c in there, and then I'm going to use this other point that was identified to find the b. So I put in a 0 for the y and a 1 for the x, and then I solve. So I need to add 1 to both sides. All right, and b to the 1 is just b, and then I need to divide both sides by 3, and then I have found my b. And then you want to rewrite the function with the a, the b, and the c, which will be f of x equals 3 times 1/3 to the x minus 1. So hopefully you did good with that. If not, I hope you made some corrections. And remember, you can always pause the video and rework examples and slow things down on your end if you need it. And good luck with your problems and your practice problems, and make sure you're asking questions if you have them. I'll see you in the next video.